Today we're going to work one more time on learning how to factor quadratics. And this is the last chance, and some of you that didn't catch it all the way, didn't do so well on your test, today is your last chance to get this down pat, because we are going to be using this for the rest of all of your algebra days. The first step is to make sure that your quadratic is in standard form. And in order to be in standard form, that means that the powers of the x's go from biggest to smallest. So here your power is 2, 1, 0. That one's in standard form. 2, 1, 0. That's in standard form. 2, 1, 0. Standard form. 4, 3, 2. Standard form. All the x's are in order from highest power to largest or to smallest power. So they're all in standard form. Then we need to check for a GCF. Not all of them will have a GCF, but if there is one, it needs to be removed. So when I look at number 1, since this 6 on the end doesn't have an x, I know that I cannot take out any x's. When I look at the numbers 5, 17, and 6, there's nothing that will divide evenly into all three of those numbers. So this one doesn't have a GCF, so we're done with step 1 for this one. Number 2, again, no x. They all three have to have x in order for me to take out an x in the GCF. And when I look at the numbers 3, 1, 10, there's nothing that divides evenly into all three of those, mainly because this one has a 1, so there's no GCF for number 2. On number 3, there's no x on this term, so I know I can't take out any x's. But when I look at the numbers, the 4, the 10, and the 6, I see that 2 can be divided evenly into all three of these numbers. So that's what I'm going to do, is take out the GCF of 2. Again, 2 is the biggest number that can divide evenly into all three of these. So I'm going to do 4 divided by 2, and the x's don't change because I'm not taking any x's out. Positive 10 divided by 2, keeping the x, and negative 6 divided by 2. So here's my quadratic with the GCF taken out. Check number 4 for a GCF. This one, they all have x's, so I can take away whatever the smallest x is. This one has 2, 3, 4. The smallest is 2, so I know I can take out 2 from each of those. I can't take out more than what the smallest one has. Then look at the numbers, 40, 10, and 5. I can look at this and see that 5 divides evenly into all of these, so I'm going to go ahead and take out the 5. Now, if you can't tell by looking if a number will divide evenly into all three of those, you could type each of these numbers into your calculator. Y equals 40 divided by x, and you could write out the factor pairs of 40. Y equals 10 divided by x, write out those factor pairs. Y equals 5 divided by x, and write out those factor pairs, and then find the biggest number that they all three have in common. That works as well. So if you get stuck and don't know what divides evenly into all three of them, you can always revert back to that. I'm going to divide each of these by 5x squared to see what I have left. So I have 40 divided by 5, 4 x's, and I'm taking 2 away, so that leaves me with 2. Negative 10 divided by 5, 3 x's, taking 2 away, which leaves me with 1. Negative 5 divided by 5, 2 x's, both of them coming out, no x's left. So I am done with step 1 on all 4 of these. I've either determined that there wasn't a GCF, or I've taken the GCF out. Now we're going to use the bottoms up method to factor these. So step 2 tells me to multiply the constant term. Constant term is the term that doesn't have the x, the end number. We're going to multiply the constant term by the coefficient of the quadratic term. That means the number in front of the x squared. And we're going to drop the quadratic coefficient. It sounds really confusing, but here's what it's saying. We're going to take the 5 and bump it to the end and multiply those together. So the 5 won't be here anymore. Not doing anything to the middle term. This 6 is going to be multiplied by the 5, so I'm going to have a plus 30 right here. Now the reason I'm doing this is it's much easier to factor quadratics that don't have a number other than the understood 1 in front of the x squared. because now I need to find two numbers that multiply together to make positive 30, but those same two numbers will add to negative 17. Now, since they multiply to make a positive but add to make a negative, I know that my factors are going to have to be a negative times a negative, because when I multiply these two negatives, that turns it positive, but when I add two negatives, it stays negative. Now, negative 1 times negative 30 makes positive 30, but these two add up to negative 31, and that's not what I need. So I'm going to find the pair that works. And this one happens to be the pair that works. Negative 2 times negative 15 is positive 30. Negative 2 plus negative 15 is negative 17. So this is the factor pair that I'm going to use. I'm going to open two sets of parentheses. My x squared is going to be an x times x. And for the 30, we have figured out that we're going to use a negative 2 and a negative 15. Now, we just need to undo what we did with this 5 right here. So since we multiplied this by 5, we're going to divide by 5 to undo that. This is step 4. We're rewriting the binomial's constant term as a fraction. We're putting them on the bottom. Now, this is very important. This is a step that several of you have been missing. If this fraction reduces, you have to reduce it before you move. If you don't know if 2 over 5 reduces or not, type it into your calculator and press math, enter, enter. If the fraction reduces, it will reduce it. If it doesn't, it will remain 2 over 5. This one does not reduce. 15 over 5 does reduce. It's the same thing as 3. 15 divided by 5 is 3, so I'm reducing it. This term I'm done with. This one that has the fraction, if there's still a fraction left, this is why we call this the bottoms up method, the bottom number needs to move up to the front. So I have my 5 in front of my x now with my minus 2, with my x minus 3. This is my final answer, and here's how I know it's correct. 5x times 1x is 5x squared. Negative 2 times negative 3 is positive 6. The middle term of negative 17 comes from multiplying these two, negative 2 times x, and these two, 5x times negative 3, and then they have to add up to whatever my middle term is, which is correct. So this is my answer, these two sets of parentheses. I'm going to do the same thing now on number 2. Okay, we've already determined there wasn't a GCF, so we're ready to bump this 3 to the end and multiply. So now I have this 3 times negative 10 turns into negative 30. So I'm looking for a factor pair that multiplies to make negative 30, but at the same time adds to make negative 1. If they're going to multiply to make a negative, that tells me that one of my factors has to be positive and one has to be negative. So you can list out all the factors that make negative 30. 1 times negative 30, 2 times negative 15, 3 times negative 10. But you could probably go ahead and guess which factor pair is going to work. Negative 6 times 5 is the pair that we should use, because negative 6 times 5 makes negative 30. Negative 6 plus 5 makes negative 1. So this is the only factor pair that will work that meets both of these conditions. So I'm going to go to the two sets of parentheses. My x squared will be x times x, and for the negative 30, we're going to use a minus 6 and a plus 5. Now we need to undo what we did with this 3. We multiplied by the 3, so I'm going to divide by 3. I'm going to check if these reduce. 6 over 3 is the same thing as 2. 5 over 3, if you type it into your calculator, stays 5 over 3 when you math enter that, so it doesn't reduce. This parenthesis here is fine because there are no fractions. This one with the fraction, I need to move the bottom to the top. X minus 2, 3x plus 5. And again, you can quickly check it. X times 3x is 3x squared. Negative 2 times 5 is negative 10. The middle term, negative 2 times 3x, and 1x times 5, adds up to negative 1x, which is what I had, and that tells me that this is the correct answer. Alright, we're going to factor number 3. Now on number 3, we took out this GCF of 2. We are not going to do anything else with it, but that's part of our answer, and it's going to stay. So just because a whole lot of you missed points on your test because you forgot to include your GCF that you took out, I'm going to go ahead and just write it down a few rows so that I don't forget about it. This is the thing that I'm factoring, the stuff inside this parenthesis. So I'm going to start by taking my 2 and bumping it to the end. So now this becomes x squared plus 5x, and the 2 times the negative 3 is negative 6. I'm looking for two numbers that multiply together to make negative 6, but add to make a positive 5. So since this is negative, I know that one term is going to have to be negative and one positive. And if I check this one, negative 1 times 6 does make negative 6. Negative 1 plus 6 makes positive 5. This is the one that works. Now, I had a lot of students that were tricked on this one because they felt like the 3 and the 2 would work, because negative 3 times 2 does make negative 6. But you see the problem, negative 3 plus 2 doesn't add up to positive 5. It adds up to negative 1. That's why I can't use the 3 and the 2. So I'm going to use the negative 1 and the 6. My parentheses for the x squared will be x times x. For the negative 6, we're going to use a minus 1 and a positive 6. And remember how we took this 2 and multiplied it, so now I'm putting the 2 back. Now I'm checking to see if anything reduces. 1 over 2 does not reduce. 6 over 2 does. It makes 3. And last step is to pull the bottom number to the top. I'm going to write one more of these 2's out here so I don't forget it. This one becomes 2x minus 1, x plus 3. Now when I check this one, I'm seeing if it matches what I had to start with. This is the one that I was factoring, not this one. This, I took the 2 out of, and it turned into this quadratic. So 2x times x is 2x squared. Negative 1 times 3 is negative 3. Negative 1 times x plus 2x times 3 adds up to positive 5x, which is what I had. So my answer is all of this. One more and then you're ready to try some. We've taken out our GCF of 5x squared, so I'm going to go ahead and drop that down for a few lines. I'm going to bump the 8 to the end to join with the 1. So this turns into x squared minus 2x, and 8 times negative 1 will give me a negative 8. I'm going to find factor pairs that multiply to make a negative 8, but add to make a negative 2. If my multiplication part is a negative number, I have to use one positive and one negative in order to keep that answer negative. So I can see that negative 8 is the same thing as negative 4 times 2, and negative 4 plus 2 adds up to negative 2. So I know that this is the correct factor pair to use, negative 4 and 2. So my parentheses become x minus 4, x plus 2. The x is making the x squared, the negative 4, and the 2 from here. And now I need to put the 8 back on the bottoms because I took the 8 to here. Now this doesn't reduce to make a whole number, but it does reduce, and you must reduce it before you pull the bottom to the top. So if you don't know what 4 over 8 reduces to, you can type into your calculator 4 divided by 8 and press math enter enter and figure out that it reduces to 1/2. Same with the 2 over 8. If you type that into your calculator and press math enter enter, it reduces to 1/4. So both of these parentheses have parts on the bottom that will move up. Don't forget about your GCF. The 2 moves up to make 2x minus 1. The 4 moves up to make 4x plus 1. 2x times 4x gives you your 8x squared. Negative 1 times 1 gives you your negative 1. Negative 1 times 4x is negative 4x. 2x times 1 is 2x. Those add up to negative 2x, so I know that this is the correct answer. That's a lot of writing on this page, but if you'll turn this page over and follow those steps, you've got problems on the back that look like this, and you need to work these 6 problems. You need to start by taking out the GCF, if there is one, on each problem, and then factor them using the bottoms-up method. And I do want to warn you that on number 2, since your leading coefficient is negative, when you take out your GCF, go ahead and take out a negative number. So you'll be dividing each of these by the negative GCF.